because okay, Node 3 and the cupola will be attached to the space station in a couple of days, but we shall have also 2 ESA astronauts flying to the space station. Roberto Vittori, who will fly in July, and next Paolo Nespoli, who will be to the space station at the end of the year for a 6 months mission. And Paolo Nespoli will see the arrival to the space station of the second ATV, Johannes Kepler, who will be launched also by the end of the year. So as you can see, it's a very busy year for ESA for what concerns the ISS. And I would like, since I have thanked NASA to start, I would like to thank the ESA member states for their continuous support to the space station. I must say that the ESA member states, they have made of ESA certainly one of the most reliable partners in the world, and I think that we are very glad to deliver. So, and I am ready, obviously, to ask any question that you can.
Well, thanks, Sean. Let's see. Talk to you a little bit about the launch tonight, but there's not really much to talk about. The count was unbelievably smooth. It went great. So you saw the end product, which was a really beautiful, spectacular morning launch, and you could really see the vehicle for a long time. I think we had some folks that still had eyes on it at about 7 minutes and 10 seconds when we hit single engine press to MECO, which, if you consider the fact that main engines are cutting off at about 8 minutes 30 seconds, that's pretty good view. So the cloud cover we thought was there was nice and thin, like we were hoping. So we had a great illustration of the last 2 days of a lot of the reasons why we have the weather rules that we do, and when we get in orbit that we carry a couple extra days for entry weather. You can just have the weather not do at all what you were thinking, and yesterday was a great example of that. We thought we were going to have a really great day. Turns out we didn't have a very good day at all, but then it started to come back towards goodness at the end. Just never got there good enough. Today overseas at TAL, we talked about our sites at Istris was a really good looking site today, and we thought we'd have that one in the bank without having to work too hard. And it turns out that one went down pretty fast, and Zaragoza, which had showers predicted on top of it, turns out to not, they didn't come in as fast as they did. So we ended up with one of our 3 good TAL sites, and that's all we needed to be able to launch today. So again, an illustration of some of the challenges of launching with the weather restrictions we have, and then some of the need for those weather rules in the first place. So it all went really well for us at the end, and happy it all came together. Focus a little bit on what we're doing now that we're in orbit. The crew got up there and they did OMS 2. Everything's successful, so we're in a nice, safe orbit. They're going to be setting themselves up for a docking on flight day 3. So after they go to bed today, they'll get up tomorrow, do their inspections of the vehicle, take a look at the thermal protection system and the reentry systems to make sure they're all clean. And then they'll go ahead and dock with the station. And then they get right to work with the node and the cupola. Basically, all 3 EVAs are going to be spent with the node, the cupola, and the PMA. We're going to relocate the cupola to its permanent location, move PMA 3 over, and then basically connect up all the hardware. We're carrying a +1 day on this mission that we can use for a variety of things. We may end up using it to help with some of the regen ECLIS systems or regenerative life support systems, which are permanent home is in Node 3, but some of them are already up in orbit right now, and we would like to move them into their permanent home, but we need to get a little bit of runtime after we deliver some fixes that we're taking up this mission. But you'll see the crew get very busy, get right to work. And the great thing is it's going to be a good example of, again, international partnerships and cooperations between the station crew and the shuttle crew, with the 6-person crew up there and the shuttle crew joining them. Everybody's got their task, everybody's got their job, and you'll see some real peak efficiencies in the way the crew's able to execute. And it's an amazing thing to watch. So looking forward to a really spectacular, successful mission. And with that, I'll let Mike talk to you.
Well, thanks. Let's see. First of all, for Jean-Jacques, we too wish we had launched yesterday, but we got a good launch off today, and we're glad to have you in orbit now. The countdown itself was really, really smooth. Sometimes you have challenging countdowns, and sometimes you have smooth ones. This was one of the smoothest ones ever, and real glad to report that. We took no problem reports during the last 6 hours of the count. Mike mentioned being able to see the orbiter about 7 minutes out. I was one of the fortunate ones that could see it out my windows of the control center. And to put it in context, that was the orbiter was off Cape Hatteras when I finally lost sight of it. So just a fabulous view. Special time for the whole team today. Again, just a terrific countdown. The team was very, very energized going into this count. A little disappointed last night with the weather that got us, but You know, we fought the weather last night. It just was not the right time to launch yesterday. So we stood down, got into it today, and it really rewarded everybody extremely well. So happy to be here, and glad to answer any questions you may have when we get to it.
Okay, thank you. We have a lot of folks here, so I'd ask you to limit it to one question and a follow-up on the first go-round. Please wait for the microphones, state your name and your affiliation and to whom you're addressing your question. And let's start up front here with Pat.
At Duggins, Alabama Public Radio. Frankly, for anyone who would like to take it, it's a cupola question. The astronauts routinely move large pieces of hardware, and comparatively speaking, it looks like the cupola is a little bit smaller. Does that make it different to handle, easier, more difficult, or not at all?
Yeah, I was going to say from a training perspective and a mass handling perspective, it's probably not much different. It actually we have really good camera views and angles now with all the external cameras that we have. We're going to do with the cupola. It's not going to be that much of a challenge, but the node is a different place than it was supposed to be when we originally baselined the layout of the station. So we are going to do some photogrammetry, which means we're going to take pictures and do some comparisons of clearances to make sure that all the predicts we have on the ground, kind of the as-built, is the same as the as-flown. Mostly with regards to the PMA relocation, not so much the cupola relocation, but from the actual robotic task itself, no, it shouldn't pose any challenge above and beyond anything else they've been doing.
I think it's just kind of standard robotic task, and then it's got the uniqueness that it has to have a pressure seal, so we'll have to do the pressure integrity checks, make sure that that's okay, make sure we don't have condensation issues like we do in any laboratory, and then also it's a robotic workstation, so it's going to have, it has some cooling in it for the windows, also some electrical lines that run up to the robotic station so that the crews can then operate the robotic arms through using the window view. So it's not only there for the nice view for the crew, it's there to perform an actual work function, which is to be there for HTV. When it comes up to dock or any of the new commercial vehicles come up, we can get a much better view with the arm when we go out and grapple.
Jim Siegel, Celebration Independent Newspaper. Could you please describe for our viewers a little bit about what the crew did after they came off of the rocket yesterday, what they did before they went to bed? What time did they go to sleep? I assume they missed the Super Bowl. And was there anything else going on kind of interest by the ground crew in preparation for today's launch?
Let's see, from the flight crew perspective, I don't have their schedule in front of me, but basically, after they came off the vehicle after the scrub, they returned to crew quarters and had some downtime basically before they went to bed. I don't recall that they did. I don't think they went out and did any flying on a 24-hour scrub. They usually don't do any of that. So they probably called it an early night and kind of had some time to relax and a chance to go tag back up with their families. And then the morning was a normal standard launch morning where they came up and prepped and got ready. I don't think they had time to sit and watch the Super Bowl, but I think they probably got some reports over the net what the score was. And speaking of the Super Bowl, we had quite a few people in the control center. We were loading our external tank, which is built in New Orleans, at the time the Super Bowl was going on. So while I was getting evil glares for having made them come in, I don't know why it was my fault, right? But made them come in for the Super Bowl, they were at least happy with the results of the game. So I got that going for me.
Chris Gephardt with NASASpaceflight.com with just a couple curiosity questions. But first off, congratulations on extremely smooth count. That was amazing to watch, and especially with no problem reports in the last 6 hours today. First curiosity question, just the frost. We could clearly see the frost on the tank tonight. And from a standpoint, what are the properties of frost liberation during ascent that makes frost acceptable to have on the tank during liftoff?
Let's see, the frost, frost isn't all that uncommon. It's just a temperature, it's environmental conditions that make it appear. And then the lighting helps a lot at night when you can see it in the xenons, it kind of glows. So you don't normally see it if we're in a different lighting condition. The frost, you're really looking at really light, fluffy stuff that kind of just forms as soon as we light up and go. There's no mass there to fall off. There's nothing that's debris that liberates. So from a frost perspective, the rules talk about when you're going to get frost and what frost leads to. You're more worried about frost that forms that then masks ice forming either underneath it or on top of it, because it from the imagery it makes it harder to detect. But we have really good techniques these days with the ice team out there, with the IR cameras that we have, and all the
the high-resolution photography we have, they can really zoom in and look exactly where that frost is. We talked about